Besides the wind, which sets up a lot of the waves that occur on the ocean, there's another force that affects shorelines, which is called the tides. So the tides are daily changes in the elevation of the surface of the ocean. And the reason tides change going up and down in elevation is caused by the gravitational force of mostly the moon. The sun also plays into it to a lesser extent, but it's primarily the moon that is affecting this. And tides can vary from place to place. We can have very large or very small variations in tides. This can have to do with things like the shape of the coastline or the shape of the bottom of the ocean basin as the water moves in and out, as the elevation of the top of the water changes during the day. So the reason we have these tides is because of the pull of the moon, and we get high tides when the pull of the moon and the sun line up like this. But it is primarily due to the moon. And an important thing to remember is we get high tides not just on the side that's being pulled towards the moon, but on the opposite side of the Earth as well. So here we're looking down on the North Pole, and we're getting a high tide on this side where the Americas are, and a high tide on the other side where Asia is. And the reason for this is we can, if we, instead of thinking of this as a solid, we think of it as a bunch of particles of water. These things are just kind of getting stretched out with this pull of gravity. The center of gravity is moving faster than the water on this edge, and that's why we get a high tide on the opposite side of the Earth, as well as the side that's being pulled towards the moon. And 90 degrees away from that, here and here, we would get low tides. So as the Earth rotates once per day, we would expect to get approximately 2 high tides and 2 low tides. And of course, the shape of the basin can have a lot to do with how much the tide is actually changing in a place. One place famous for its large changes in elevation of the top of the bay or the top of the ocean due to these tides is the Bay of Fundy, F-U-N-D-Y, which is located just north of Nova Scotia. And here we see the same ship during high tide when it's floating on the water, and during low tide when all of the water has been drained away. In the Bay of Fundy, they get tidal variations from low water to high water of approximately 10 feet. So things are really going up and down twice a day. It's happening all the time. One thing to remember or think about as these tides occur is that in most places where if you have a flat shoreline or a straight shoreline, the water is going to come up and down, but it's really not going to change things that much. But if you have some sort of inlet or opening to a bay or to an area behind a barrier island, we can get large variations of the flow of water through that inlet when we go from high tide to low tide. The place that would happen is not at high tide or low tide, when there really wouldn't be much movement of the current at all, but as we're going from high tide to low tide, we would expect an ebb current. It would be moving from the bay out through the inlet and into the open ocean. And then moving from low tide to high tide, we would be flooding that bay or increasing the elevation of the water in that bay. And there we would have a lot of water added through a small inlet over a large area. And so that's called a flood tide or a flood current, as the water flows in from the ocean into that bay through the inlet. So once again, this is happening because we have a narrow inlet that's supplying water for a very large area behind it. In this case, a lagoon, but same thing if it was a bay here. So during ebb tide, things are flowing out of the basin. And of course, this could be transporting sediment out of the basin. It could be transporting sand or other sediment out of the basin. But as soon as that sediment gets out here in the ocean, it just starts getting reworked by the waves. However, during flood current, when the tidal level is rising, the water is getting higher and higher in the lagoon, and all of that water is coming through one area, through this little opening in the inlet of the barrier island. All of that water is going from an area where it's moving back and forth quickly to a pretty still area here in the lagoon. So we can actually get deposition of sand and other sediment during flood tide when the water is moving through the inlet and into the protected area behind the barrier island or spit. And this sort of deposit is called a tidal delta because it is very similar to a delta. We have fast moving water, not through a river channel now, but through an inlet in a barrier island. But once it gets in here, it's much more slow moving water. It's like it's just being dumped in still water, so that then the sand and other sediment is able to settle to the bottom, and we get these tidal deltas that are built. They're only built on the protected side of the barrier island, and there has to be this inlet for this to happen. But this is one landform that's specifically associated with the tide.